So once again, back with data structures. So today's class we will get more into doubly linked list as well as the advantages of abstract data type. Of course, you can reach me at dr.christoananth@gmail.com. So before beginning today's session, let me thank God for anything, for food, for knowledge, for studies, for anything and everything in this world. You thank God. As for me, I thank God for giving me this golden opportunity to deliver this useful session, to share my knowledge among my fellow national, international participants and students. So this is what we are going to discuss at a glance. We are going to discuss about doubly linked list, and then we discuss about the advantages as well as disadvantages of the doubly linked list over the singly linked list, and then we discuss about the insertion of the node as well as deletion of the node. So that's a advantage that you enjoy with the case of singly linked list. And then here in this particular class we go for 5 steps to add a node at the front, and then you go with some modification and you go for 7 steps to add a node at the front, and then we discuss about the implementation of the approach, and then we discuss about a complete working program to test the above function. We discuss about ADT, that is the second part of today's class, which is abstract data type, and then we discuss about the what do you mean by abstract, what is data, and then we discuss about some examples, and then finally we end up with the advantages of ADT. Okay, so maybe if there is time, I will discuss about the open-ended project that is pretty much new to you. Okay, and then of course we have at regular intervals we have some short videos to discuss the knowledge in our topics. So this is a doubly linked list. There's difference between a singly linked list as well as doubly linked list. Okay, I'll give you the difference. As you see in the diagram, we have A, B, C and D. First of all, the head points to A. Now A is the head. Okay, it is pointing to B, B points to C, C points to D. Okay, and then this D is pointing to null. It goes out. Okay, from D it goes to previous, D to C, C to B, B to A, and A null, it goes out. So here it goes, here it goes. Okay, so this is a doubly linked list where you have an extra pointer called as the previous pointer. So you have previous as well as next along with some data and information. Okay, this is what you have with a singly linked list. Okay, so this is how you try to represent a doubly linked list node in the C language. For example, the node of a doubly linked list will have class node. Okay, and then you have public. You don't term it as private, but you term it as public. Okay, int data, and then you have two cases: node star next, it is the pointer to the next node, and then node star previous, it is the pointer to the previous node. Remember in the diagram we had next, 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 previous, 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 previous. Okay, so this is the doubly linked list. So we have several advantages. We also have some disadvantages as well. So with the case of advantages, the doubly linked list, either you can go in the forward direction or maybe you can go in the reverse direction. Okay, but in the case of singly linked list, only one way. You go to Samarkand to Tashkent, you go out. Don't come into Samarkand. Okay, but with the case of doubly linked list, you can come once again. You spend 6 hours or 7 hours, you can come once again. Okay, right. So and then the delete operation in DLL is generally more efficient, and also you can add a node. You know, you can insert a new node before a given node. Maybe if there is one particular node, you can add it here, or maybe you can add it here. No problem. But in the singly linked list, you cannot add it. Only you can add it in the front, or maybe you can add it at the end, not in the middle. Okay, right? And also in singly linked list, in order to delete a node, the pointer to the previous node is actually needed. Okay, so the pointer to the previous node is actually needed in a singly linked list, but doubly linked list you don't have to. Okay, and in a doubly linked list we can get the previous node using the previous pointer. Okay, but still there are some disadvantages where you need some extra space. Okay, you need some extra space for the previous pointer, but in singly linked list you don't have to need a extra space, so that's a disadvantage of the doubly linked list. Okay, but still, on the positive side you can implement doubly linked list with a single pointer, but still you have to have an extra space. That's a disadvantage. And all operations require a extra pointer. Okay, for example, in the case of insertion we have to modify the previous pointers, only then we can insert a particular node. So you have to modify the previous pointer along with the next pointer. Okay, only then you can insert a particular node. So that's a small disadvantage with the doubly linked list. We consider an example of how you try to add or maybe insert a node. This insertion of node in a singly linked list, it can happen only at the start or maybe at the end. But in the case of doubly linked list, we can add it in the start, we can add it at the end. Maybe inside the node you can add, maybe before the node you can add, after the node you can add wherever you want to. So that's a way you add it in a doubly linked list.
I have a little question. What kind of reason we should use this doubly linked?
Doubly linked list generally for connecting. Maybe if you are, maybe let us take in the case, if you are in one particular location, if you are getting some information, okay, you are trying to store the information. Okay, for example, I am in class 206. Okay, I am talking to you all. Okay, maybe I am moving to class 203. Okay, maybe I am talking to somebody. Suddenly Professor Akmal comes. Let us take in the case. Okay, I'm meeting in the second floor, and he asks, "What have you been doing all this time?" Okay, so I'm telling my previous node is actually 206. I was talking to everybody. Okay, then I went to class 203. I was talking to everybody. I was handling the class. So I am getting the information about 206, 203, and I am giving it to Professor Akmal. So all the connection is very, very important. In 206, I was talking to you, I was seeing you, I was having a word with you, and in 203, maybe 2, 3 or 4, I was mingling. So this is how the connection, storing all this information, and you are pointing to the next one.
And is it only C language, or we can use
C, C++, you can use. Java also you can use. Java, Python you can use. But this is data structures. Data structures, it's all about algorithms and methods. You can use it in any programming language. Okay. Now comes a 5-step process. Okay, a 5-step process where a new node is always added before the head of the given linked list. Okay. So the newly added node becomes the new head of the doubly linked list. Okay. For example, let us consider an example 10152025. Okay. Now 1 is the head. First one is the head. Okay, that 1 is the head. Okay, and then for example, let us take in the case we add an item 5. We add 5. Okay, maybe at the front. So the linked list becomes 510152025. Okay, so 5 becomes the head. Okay, 5 becomes head. So for this case, for adding at the front, we use a push operation. Okay. So you are going to change the head pointer to the pointer of the next node. Okay, so this is how you do A, B, C, D. Okay, so it's going to next, and then previous. Okay, and from A, in the previous case we had from A pointing to null, and from D pointing to null. But here in this case from A, we are going to point to a new node which is E. Okay, so from A it is going to point to E. Okay, and from E it is going to go for null. So in the previous case A was a head, but in this case, E was the head. A is no longer the head.
Yeah.
Is it such an algorithm?
So this is how you add a node at the front, okay, given a reference pointer to the head of the list, okay, and an int, which is going to insert a new node on the front of the list. So you have void push node head reference int new data, and then first of all you are going to allocate the node. So node multiplied by new node becomes the new node, and then you are going to append the data or maybe add in the data. So new node data becomes the new data, okay, and you are going to make the next of the new node as the head. For example, in this case we made E as the head. In the previous case it was A as a head. Okay, so new node next is equal to head reference and new node previous is equal to null. Okay, and similarly this is what this null is actually the end part. The end part, E was pointing to null and D was pointing to null. Okay, that's what we are going to do. So new node previous is equal to null, okay, and you are going to change the previous of the head node to the new node. So if head reference is not equal to null, in the first case you check is equal to null. In this case, if head reference is not equal to null, then you are going to go with head reference previous is equal to the new node, and you are going to point to the new node, which is head reference is equal to new node.
But I didn't see any variables in the syntax. No, next slide. Is it the same?
General.
Ah,
This is the general syntax. General way how you try to. You don't add A, B, C, and D and O. So.
I think about A, B, C, and D is a variable.
It's a general way where you can include as many variables you can. Okay, so the only extra step is to change the previous of the head. So that's a 5-step process. Second thing, you add a node after a given node. Okay, so this is a 7-step process. So 2 extra modifications you have to do. So we are given a pointer to the node as the previous node, and the new node is inserted after the given node. So here you have A, B, okay, C, D. There is no communication between B and C, okay, but instead from B it is going to point to E and E to C and D. Okay, right. So given a node as a previous node, you insert a new node after the given node. Okay, so void insert after node multiply by previous node int new data. Okay, so you go first of all the same process goes. Okay, same steps repeats. Okay, check if the given previous node is equal to null. Same in the previous also it was same. So if previous node is equal to null, so see out the given previous node cannot be null and return. Next what you do, you append a new node, you allocate a new node. So node multiplied by new node is equal to new node, and you add the data, new node data equal to new data. And the step 4, make the next of the new node as the next of the previous node. So previous node equal to new node, so new node next is equal to previous node next. Okay, step 5, make the next of the previous node as the new node. Okay, so previous node next is equal to new node. And finally step 6, make previous node as the previous of the new node. So new node previous is equal to new previous node. And finally the step 7, change the previous of the new node next node. Okay, so finally you check whether it is equal to null. The last step would be not equal to null. So if new node next is not equal to null, so new node, okay, next, both the case for the next as well as the previous, you set it for the new node. So 5 steps are same. 5 steps are the same. Only thing for the remaining 2 steps, you are going to change the previous pointer of the new node and the previous pointer of the new node's next node. So this is how you do this one. This is what I said. You can add it at the front, you can add it at the last. Maybe in the node you can add it in the front, you can add it in the last. Okay, so add a node at the end. It's a 7-step process. So this is what you do. So this is step 4, add a node before a given node. So you have added after, but now you are going to add it before. Okay, So let the pointer to the given node be the next node, and the data of the next new node be added as a new data. So you are going to check. The first step remains the same, whether it is equal to null, else return. Okay, so check if the next node is null or not. If it is null, return from the function, because any new node cannot be added before a null, and then you allocate the memory, you add the data. Okay, so with the case of allocation of memory, you call it the new node. Okay, and you set the new node data to be the new data, and the set the previous point of the new node as the previous node of the next node. So new node previous is equal to next node previous. I think the coding is all the same. New node previous, new node next, same thing. I think with the help of this diagram you can understand things better. Okay, so you have A, B, C, D. Okay, A is the head. Okay, from A it is going to B. Okay, from B we have previous node to be A and next node to be C. But only thing there is no communication between A and C. Yeah. No communication between A and C. Okay, from C it is going to point to D. There is no communication between A and C, so forget about that. Okay, so it is A, it's going to be B to C, C to D.
B don't know, A don't know C, yeah.
C don't
C
know.
don't know,
B is the interpreter.
yes, yeah.
Okay, right. Okay. So from A, it's going to be B, it's going to C. Okay, so from C, the previous is actually B. Okay, from A, the next is actually B. Okay, right. So this is how it is.
D is
C doesn't return to B.
Yeah, from C, no, it's going like previous. So the output in the case of doubly linked list, traversal in the forward direction it is 91576. In the reverse direction it is 67519. Similarly, we express the same with the help of a C++ program. Okay, to demonstrate all insertion methods. So you have hash include bits slash std c++.h using namespace std. Okay, so you have a linked list node. So you have class node, public data type, in data, node star next, node star previous. Okay, and you have a reference to the head of the list, and in data, which is going to insert a new node on the front of the list. So you have the same thing like void push node head reference int new data. Same thing you are doing. Allocate the node, put in the data, make the next of the new node as a head. Okay, and you are going to change the previous of the head node to the new node, and you are going to move the head of the head to the point of the new node. Okay, so you have the same step we are going to do. So the first step is allocating the node. So what you do, node multiplied by new node, you get new node, and you have to add in the data. So new node data equal to new data. And the third step, make the next of the new node as the head and previous as null. The previous thing you tend to forget, you tend to leave. Okay, so new node next is equal to head reference, and new node previous is equal to null. And what you are going to do, you are going to change the previous of the head node to the new node. Okay, so if this head reference is not equal to null, so head reference previous is equal to new node, and you are going to move this head to the point to the new node. So head ref equal to new node. So this is what you are going to do. So our program was not this one. You are going to add, you are going to insert. Okay, so this is what you are going to go. So given a node as the previous node, you are going to insert a new node after the given node. Okay, so void insert after. So this is the important statement here. Void insert after node multiplied by previous node int new data. You're going to check if the given previous node is equal to null. So within that 5-step process, again you are repeating the same thing. You are checking whether it is equal to null. So if previous node is equal to null, then see out the given previous node cannot be null. Okay, same thing. Allocate new node. So node multiplied by new node equal to new node. Put in the data. New node data equal to new data. New node next equal to previous node next. Previous node next is equal to new node. So goes on.
Yeah, nice.
Okay, so new node previous equal to previous node. Finally, the step 7 would be if new node next is not equal to null, then new node next previous, both the cases equal to new node. Okay, so the process still remains the same, where you tend to add in the data, new node data equal to new data, new node next is equal to null, and if this head reference is equal to null, so you go with new node previous is equal to null and head reference is equal to new node, and finally you return. So this process continues on and on, else till you traverse till the last node. Okay, so while last next is not equal to null, so last equal to last next. Okay, and then last next is equal to new node, and finally make the last node as the previous of the new node. So new node previous equal to last, and then return. Okay, so next, the next part of the program, it's actually printing the contents of the linked list starting from the given node. So void print list node star node. So node last you are going to go, and traversal in the forward direction. So you go with the traversal in the forward direction as well as traversal in the reverse direction. So traversal in the forward direction while node is not equal to null. So see out node data, and the last is equal to node and node equal to node next. Similarly, the same thing with the case of traversal in the reverse direction. While last is not equal to null, so see out last data, okay, and then last equal to last previous. Finally, after finishing up all this stuff, we have to go with the driver program to test the above function. So in main function, node head equal to null, okay, and then you are going to append or maybe add or maybe insert 6, okay. So at the head you go with 6, okay, and the linked list becomes, now from the 6 it becomes 7, okay, right. So push head 7, okay, and then push, you add 1 at the beginning, okay, so 1, okay, and then you insert 4 at the end, okay. So append, so whenever you go with append, okay, like it's going to go with the end, okay, so like 4, okay, and then the list goes on and on. You tend to add 8, and then after 7, okay, and then 6, then 4, it goes on. So insert after head next it is 8, and then see out you're going to go with the print list head. So this is how you try to add, like you added 8 and then 7, sorry, 1 7 8 6 4, you are adding, right. So same thing, 1 7 5 8 6 4, you are adding in the forward direction, and similarly you are traversing in the reverse direction, 4 6 8 5 7 1.
This is an append function.
Append, sorry,
Previous speech.
which
What
one?
is the append function?
Append means adding.
Yes, yes.
Suppose if I am storing here, let us take in the case he is Mr. ABC. Let us take in the case. Now you come and sit over here. Now immediately he will go here.
Pushing.
And after that,
I go out.
yeah, you go out. Push it and you go there. Yes. Same thing from here. You are going to come here. He will come here. He will then push, go out. So which is ADT, it's an abstract data type. So you are going to focus on what actually it does. So we'll discuss more about abstract, we will discuss more about data type also. So with ADT we have, I think I discussed this earlier, stacks and queues are very good example of abstract data type. So stack with the push as well as pop operation. Push means you push it, pop means delete it, you try to delete it. So both the push and the pop operations with the stack, it's being implemented using this array, or maybe using singly linked list or maybe doubly linked list, okay. So there's also a complex logic behind this push and pop operation. So we discuss about this data type even. So data type means it's actually a variable where you will have many values into it. So this variable will be performing like several tasks. Maybe you can add it, you can append it, you can delete it, you want to. So some basic data types in C, you have int, character, float, as well as double. So the data type and abstract, maybe with the case of data type, we have primitive data type as well as non-primitive data type. So primitive data type is nothing but a data where an item with certain characteristics and another one is permissible operation on the data. For example, let us take in the case an int variable, integer variable. It can range from minus 32,768 to plus 32,767. Generally, you can have different operation. You can have addition operation, subtraction operation, multiplication operation, slash division operation, and so on. So if we declare a variable of an abstract data type, then the above operation should be performed on it. So with the case of abstract, it hides the complex internal implementation, only show the functionality. So the same case we can do it in C programming also, where we have several methods to perform various tasks associated with it. Even with the case of several methods which we are talking about, several operations also we can do it. For example, in the stack or maybe queue data structures, we have some predefined operations. Maybe in the stack, maybe we will have like a push and then pop. We have top operation also. Similarly, with the case of array data structures also, we have some similar operations and tasks. So, but the users are not aware about how the data is being stored in the memory. So, using this push as well as pop operation, maybe you can go for insertion or maybe deletion operations as well. So, these are the advantages of abstract data types. One is the representation independence. So, how you try to represent it is independent. So most of the program becomes independent of the abstract data types representation, so that representation can be improved without breaking the entire program. And in the case of modularity, the different parts of the program become less dependent on other parts and on how those other parts are being implemented. And similarly, interchangeability of parts. Even if you try to interchange, the performance characteristics doesn't get degraded. So that's an advantage. Even with abstract data types, it's very easier for each part of the program to use an implementation of its data types that will be more efficient for that particular part of the program. Even localizing the bugs, whenever you have to find the errors, some internal errors that are associated with the implementation of abstract data type. So such bugs are seen as local with abstract data type, and in turn it won't be caused by the code that uses the abstract data type. And similarly, we have abstraction also. Abstraction means it's something related to an imaginary data type that we are trying to add. It's a very user friendly, so user doesn't have to need to have to understand. So only if you know to work, then it's better for you. And then you have encapsulation. Encapsulation, I have explained this many times. Like for example, I remember in the online classes when I was teaching, whenever you are driving the car, you need not have to know what mechanism is needed for applying the brake, what mechanism is needed to accelerate. You need not have to know about it, but you can drive the car.
Yeah, just press.
Just press. That's it. Yeah. For example, if you are working in the car industry, okay, for example, maybe let us take in the case, when you are going to a bank, maybe you will ask how to transfer the money, how to change from sums to dollars, you will ask. But internal procedure, they will not tell to you. Okay, that is encapsulation. Hiding. Okay. Okay. So this process makes sure that the data cannot be corrupt. So you are ensuring good privacy, good authentication, so it doesn't have any errors. So this is what you call it to be black boxing. Similar to using incognito mode in your Google Chrome. It's hiding.
Yeah, exactly.
And another advantage is that it's localizing the changes. Okay, so let's say take in the case the programmer wants to change how this abstract data type is being represented. So definitely without affecting the code, we can actually go for ensuring good privacy and authentication as well. And we can have a robust, reliable program even. So that's a good ability to catch the errors. You can prevent all the exceptions. This is what I was discussing you. Pretty much new to you, but the best one for you.